Okay, so this is going to start the series of the different tracts that we were talking about. And we're going to have, let's remember the columns real quick. The dorsal column, we got the lateral columns, right? And the ventral columns. What were these? These were the white columns, right? The dorsal white column, the lateral white column, the ventral white column. Why is it the white column? It's got all our white matter in it. What's this? This is the gray matter. We have the posterior gray horn and the anterior gray horn. These horns are going to help the tracts and the fibers flow and like help connect everything, but the tracts are in the white matter. Let's remember that. So this video is going to be on the dorsal column. So this is going to be on the first pathway, and it's going to be known as the medial luminiscul pathway. Why is that the name of it? We'll get to it. Okay, the next video I'm going to make, if you want to watch it right now, it's going to be the lateral column tracts, and it's going to be the anterolateral system, also known as the spinal thalamic tract. I don't know, there's two different names. If you want to watch that now, just like click right here. And the last video I'm going to make on the spinal tracts is going to be the ventral column. This is going to be the spinocerebellar tracts. Again, if you want to watch that right now, just click right here. However, I think the best way to go through this is go from obviously top to bottom, dorsal to lateral to ventral. It works for me, but whatever floats your boat. So let's remember for the medial luminiscul pathway, it's the dorsal column, right? Where are all the fibers going? They're going up. Why are they going up? Well, they're going to the brain, and this column only has ascending tracts. So if it's an ascending tract, what does it mean? Ascending is going to mean sensory. Okay, so this whole entire tract is going to be a sensory tract only, no motor function. What is a motor one? What's a motor tract? Well, that's going to be a descending. So descending is going to be motor. That's going to be in the lateral and the ventral columns, right? Let me write lateral right here, just so you guys know it's on both sides. Okay, so just let's remember real quick. Ascending, dorsal, only sensory. All right, we're going to keep going. Okay, so the first pathway is the dorsal Luminiscus pathway, like we said. Just remember where he is, right up there. Going up, right? Boom. Okay, so this pathway is just for this region. Now we're going to have two different tracts that come from this pathway. What are they? The Fasciculus Gracilis and the Fasciculus Cutaneus. What does this mean? Okay, so if we have our, let me redraw real quick. We have our guy, right? We're going to do that, right? So you know this is the dorsal column. We're going to have a tract like that and another tract like that. Okay, what does this mean? Well, you know the body helps each other out. So the first one, the Fasciculus Gracilis, right? It's for T6 and below. What does that mean? Spinal column, right? We have the cervical vertebrae, thoracics, lumbar, sacral. This is so repetitive. And coccygeal. Okay, so if it's talking about T6 and below, we put T6 right there, right? So any nerve or any like response that's got to go through a tract to reach our brain, any sensory stimuli, it's got to travel through T5 and above or T6 and below for this tract. Okay, so if we're talking about what? Gracilis, I just think gracilis as in, I took this from a YouTube video, but I think gracilis, I think of it as the gracilis muscle, so I'm going to think of the lower leg region. So whenever you say Fasciculus Gracilis, remember this means the lower leg. That makes sense. If it's T6 and below, most of these like fibers, like the L, the lumbar, the sacral, this is all innervating lower nerves, like our thighs, our legs, our like calves, etc. Okay, and now if we go T5 and above, right, that's the Fasciculus Cutaneus. Okay, well, all you gotta remember is the other side. I mean, gracilis is below, you know the leg, and then cutaneous is gonna be above. So, I don't know how you wanna remember it, whatever you wanna do, but just know it's T5 and above, and it makes sense because what? What's above T5? Well, all the cervicals, and what is in the cervical? The brachial plexus. So it makes sense for the upper body, say just think of the upper arm, C5 through T1, cervical plexus, it would make sense for it to be innervated by T5 and above. Okay, I know we're on a little tangent there, but what does this mean? Okay, so the first one is going to be, I'm going to talk about the, what's his name? The Fasciculus Gracilis, right? He's going to go medial. So, let me see right here. So you got this, right? Now it's going to have our body symmetrical, so you're going to have left, right, left, right. So I'm going to draw 4 boxes. 1, 2, 3, 4. Okay, so the Fasciculus Gracilis, right? He's going to target which ones? Well, he's going to run medially. So he's going to go medially through the body. The Fasciculus cutaneus, he's going to be a little bit lateral, so he's going to be on the lateral sides. All right, how does this correlate to anything? Well, if we draw one more diagram, and I just split it down the middle, right? So if we split it down the middle, you're going to have 4 on this side, right? 4 of those boxes, and 4 on the other side because our body's symmetrical. Which ones are going to be most medial? Well, we said Fasciculus Gracilis. What is Fasciculus Gracilis? Sacral, lumbar, right? So the sacral, lumbar, and some of the thoracic, but we'll group that after. And then what's going to be more lateral to that? Well, the thoracic and the cervical. So thoracic and cervical. I know this is kind of not on the path that I'm trying to follow, but just another thing to always remember. When the fiber's running up, just know it goes from the sacral region to the cervical. We talked about in the last video with the spinal cord and how the spinal cord, it grew more and more white matter as you ascended up. Because why? As you added another layer, you needed to get a little bit bigger. So as you add from the sacral, right, the bottom, or you could even say coccygeal, but from the sacral, you add a layer to lumbar, add another layer, thoracic, add another layer, cervical. Just growing it bigger, 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 more white matter. A little bit of a tangent, but I just wanted to relate it all together. Now, what is the type of fiber? We already said it. It's a sensory fiber, right? Because it's the or what type of tract is it? I apologize. It's a sensory tract because it's ascending. It's only ascending, right? Only going to the brain. It's not a descending tract. All right, so we know it's a sensory. What is it like targeting? What sensory information? Okay, the sensory information is going to be fine touch. This is known as 2-point touch. What's 2-point touch? Someone tells you to close your eyes and they tap your arm, right? If they tap with 2 fingers, you're like, oh, is that 1 or 2 fingers? Okay, it feels like 2. And now I'm not looking on purpose, if you tap with 1 finger, you're like, oh, it feels like 1. You could distinguish between 2 fingers or 1 finger. Okay, so it's fine touch. Also pressure, it's another thing. Stretch, vibration, and now the biggest one, proprioception. This is our 3D orientation of our body in space. The best way I could explain it to us, or to you. If your eyes are closed, right, you know you're standing. If your eyes are closed and you lift your arm over your head, how do you know your arm's over your head? These tracts are determining proprioception. They know where your body is in space, in 3D space, with your eyes closed or not. You could have your eyes closed and you could be like, okay, I'm going to move my left arm, I'm going to abduct it, right? So if I abduct it, I'm like, okay, I know my arm's abducted even though I can't even see it. That's what proprioception is. Now, what type of fiber, like the myelination of the fiber? So there's different types of myelination we should talk about. And there's different fibers, and it's alpha, beta, or C. I don't know what C even stands for, but A, B, or C, right? It's not alpha, it's A, B, or C. Now, with A has a bunch of different fibers as well. Which fibers are we going to talk about? Well, luckily, for this track, we're going to talk about only A fibers. Which ones are these? Okay, before I say it, A is alpha, right? Alpha meaning the best, the strongest, the fastest. So the alpha fibers, the A fibers are the fastest. The C fibers are the slowest. That's the least myelinated. A is the most myelinated, alpha. C, least myelinated, slowest. B, middle myelinated, right? A little fast, a little slow, it's in the middle. Just remember that A is the fastest. Okay, so now if we break him into different branches, he has AA. Oh, so you know he's got to be the fastest of those because A is the fastest. And what's he going to stimulate? He's going to stimulate the muscle spindles, the Golgi tendon organs. Okay, so the muscle spindles, we talked about them a while ago. They're extrafusal and intrafusal fibers. But the only ones that we're talking about have to deal with stretch. So those are the intrafusal fibers. And we said that there's nuclear bag and nuclear chain, but we'll get to it in 1 second. I don't want to rush. And then the Golgi tendon organs were the tendons that connect our bones to our muscles, and they told us if we were stretching too much or too little, etc. We'll get there again. That's AA. AB now is for pressure, touch, and vibration. Okay. So pressure is like how much pressure if you're vibrating. And then what's the last one? Pressure and touch. So if you're being touched or not. Okay. So that's AB. Middle, it's in the middle. Not the fastest, not the slowest. And then alpha delta, or A delta. He's going to be for pin, prick, or pain. So what's that? If you get pricked with a needle, like a little thumbtack, something like that, right? A little bit of pain. These are, don't get me wrong, these are still the fastest fibers, but out of the three, alpha delta is the slowest. If you were to say, who's faster, B or alpha delta is going to be the fastest. Because all of these guys are faster than B and C. However, out of all the A's, alpha is the fastest, obviously, then beta, then delta. But, just something to talk about, just a fun fact, I guess. Now, what do we say? Fine touch. How are we going to differentiate between what is what? Well, if you look back in one of the videos I talked about skin, we know Meissner's corpuscle is for fine touch. We have Merkel's disc is also for touch. We have the Pacinian corpuscle. What was he for? He was for vibrations. We have the paratracheal nerve endings. So these are just going to be nerve endings that help deal with different senses. We're going to have Ruffinian's corpuscle, which is for stretch. We're also going to have, now what we said, the Golgi tendon organ. Remember where he was? Right by the bone and the muscle. So if I'm stretching my arm, right? Stretching, I'm going to feel that little pain, that little like, you know when you're stretching your hamstrings a lot and you feel that like little sensation in the back of your leg? Well, yeah, that's from the Golgi tendon organs. He's telling you to, whoa, buddy. Don't overstretch me. Like, slow down. Like, I don't want to pop. I don't want to break. I don't want to snap off the bone. That's going to be your Golgi tendon. The last one is going to be the muscle spindles. Which ones? Intrafusal fibers, not extrafusal. Intrafusal. Why intrafusal? Well, intrafusal fiber is the sensory. Extrafusal is the motor. And what are we talking about? Ascending tracts, only sensory. Okay, and then you have nuclear chain and nuclear bag. Not too important, but remember your nuclear chain was the one that was straight down. And nuclear bag was the one that kind of like bubbled out. He had a lot of things in it. He detected both speed and length. Nuclear chain just did length, but not really part of this video. Now, whatever stimulus you get, say you get multiple stimuluses, right? They're all going to converge into one fiber or to one root, right? And what's this root going to be called? It's going to be called a dorsal root ganglia. Okay. What is this going to be? Well, if you have a bunch of nerves or a bunch of things converging on each other, we're going to call it an order. Okay, so the first order neuron is going to be all of these things converging and forming the dorsal root ganglia. Makes sense. If it's an order, so we're like, okay, what's the first order? Pain, temperature, vibration, right? Not temperature, that's not a part of this one, sorry. Pain, vibration, like a prick, a stretch, all converging. Dorsal root ganglia, first order. Boom, we're good. Now, what we have to know for this dorsal column, the middle Luminiscus pathway, right? When we converge, when we travel up the spinal cord, we're going to be on the ipsilateral side. Whoa. Spinal cord, right? We're traveling up, we're going on the same side. What is ipsilateral? Same. If it was contralateral, it would be like this. It would travel up. You'd be like, nope, I'm switching, I'm going to this side. I don't know why they do that, but, well, I do know why. We're going to talk about it in a little bit. But for now, just know ipsilateral is for this pathway when it travels up the spinal cord. Not the whole way, just up the spinal cord. What's the end goal? Like, where's our end goal? Well, that's going to be in the brain. So when we get to the brain, that's when things might change a little bit, but not a lot. We'll be fine. Okay, so now for the fun stuff, or the exciting stuff. I don't know. I think it's exciting. I think it's really cool, however, like, God designed us, like, how the body does just so many different things and functions. I think it's interesting, but whatever. Who cares what I like? So now, we said the dorsal root ganglia, right? What does he do? Well, he converge, right? Or he was like, everyone stimulated or like converged onto him. And what did he form? Well, he comes over here. He's the first order neuron. Now, I know I have it split two ways. It shouldn't be split two ways. How should it be? Let me just do it like that, right? If you're getting these things, right, all the different sensations and stuff from above T5, we're going to come above T5. So this represents all the spinal column like regions above where? The thoracic, the fifth spinal nerve, right? Above thoracic 5. Okay, now if all these things are coming from where? So I'm just going to draw them like that. So if he's coming above T5 and up, we're going that way. And where are we going to stimulate to? Like, what are we going to hit? Well, fasciculus cutaneous. The fasciculus cutaneous is going to, I have T6, but surely T5 and above. Okay, so if we're coming above, we're going to go here, fasciculus cutaneous. I have them in purple. Now, if we're coming from below T6, so T6 and below, where's he going to be from? Legs, you know, who knows? Whatever the sensation, wherever it comes from, lower side, going fasciculus gracilis. Okay, so he's going down here. However, what did we say? As you ascend up the spinal column, what occurs? The white matter grows, the gray matter shrinks. So these fibers from the fasciculus gracilis are eventually going to be where? They're eventually going to join with the fasciculus cutaneous. Obviously, we said that. They're all going to join together when we're going to the brain. When we're going down, like motor, they're just going to like start leaving, right? They're going to hop off the train. Okay, so notice, before I move on, I have it coming from both sides, right? Fasciculus gracilis is getting information from both sides. And then fasciculus cutaneous is getting information from both sides. Why? I just wanted to illustrate that the body's symmetrical here. However, say I just got pain on the right side of my forearm, right? Where's he going to come from? Well, he's only going to come from the right side. He's not going to come from both. It's only on the right side. If I got pain from my left knee, right? My left knee sensation. Where's he going to come from? Well, he's going to be on the gracilis region, but where? The left side. Whatever. For this system, we're ipsilateral, same side. Remember? Same side of the spinal cord. Okay. Now, before I get too carried away, what else do I want to mention here? Okay, where is it traveling through? Well, it's traveling through what? The top part. And what's the top part? The posterior gray horn. What the hell is that? We talked about the gray horn, right? And what was the gray horn for? Or what was the horns for? We have the posterior gray horn and the anterior gray. Well, we said the posterior was for sensory information through the which rami? Dorsal rami. And we said the anterior was for motor information, right? That exited that. Now, if we have the sensory information, I'm sorry, not just the dorsal rami. It could be the dorsal or ventral rami, but it converges into this dorsal root. Like that. Okay, so now if we're going into the posterior gray horn, and this is only ascending. Remember, this tract is only ascending. Where is he going to go? Well, he's not going to travel down and come out and do a motor thing. Oh, no. He is going to be like, all right, well, screw it. I'm hopping onto the train. He's like, nope. He jumps into the white matter. Okay. What does the green guy do? Well, the fasciculus gracilis. Let's take it from the top. Any of these sensations, right? Dorsal root ganglia. Dorsal root ganglia through the where? Posterior gray horn. Not traveling through the anterior because it's not doing any motor function. Goes through the posterior gray horn, sensory. He's like, screw it, I'm hopping on the train. Into the white matter. What type of white matter is this? We said it. This is the, right over here. Oh, you can't see in the video. The dorsal column. Remember, the top is the dorsal column. The sides are the lateral. And the bottom is the ventral. Okay, so we're in the dorsal column. We're ascending. I keep reiterating this because it's really, really important. Okay, so the fasciculus gracilis is like, all right, I'm out of T6. I'm joining T5 now. He's in T5. Say this is T5, right? It's going to ascend all the way up to where? C1, the cervical, right? All the way to the, cervical, all the way to the top. Okay, so now we're keep going. Axis, atlas, etc. The spinal cord, we're trying to get to where? The brain. Okay, so now, the fasciculus cutaneous, we said was lateral, and fasciculus gracilis, we said was medial. Okay, we said why. Remember from the spinal cord diagram, how the nerves just like jump in and they like start helping each other out, where they all start going through the white matter? That's why. Okay, so the fasciculus cutaneous is going to come and he's going to join to something right here. What is this purple circle called? This is going to be the nucleus cutaneous. Okay, so instead of a fasciculus, it's called a nucleus, but it's the same name. And the fasciculus gracilis is going to join to what? Well, if this is the same name, this has got to be the same name. He's going to be the nucleus gracilis. Decent. Not bad. Now, when it gets to this nucleus region, right? What is this called? This is really at the medulla oblongata. That's where it's at. And they're going to converge together. They're going to cross over, right? And what is it called before they cross over, right? Once they stimulate or they join to another fiber, what is this? Second order neuron. So when they stimulate, right, or target, and then they cross over. Remember we said when the nerves crossed over together over here, all these things, they formed the dorsal root ganglia, which was the first order neuron. Good. These things cross over, they're going to form the second order neuron, because this is the second conversion that they're making. Nowhere else do you see the second conversion of things joining, right? Negative. Boom. Now, what is this called? When they converge together, they flip-flop, unfortunately. And this is the internal accruent fibers, right? Now, the internal accruent fibers, whatever, they're going to pass up. What happens when they pass up through the brainstem? Well, this side is going to be the right medial lemniscus, right? Right side. And this side is going to be the left medial lemniscus. Whoa. Wasn't our pathway called something? Yeah. This whole entire pathway is called the medial Luminiscus pathway. Through the where? Dorsal white column. Holy crap. So all this stuff was just to get to this, the right medial lemniscus and left medial lemniscus? Unfortunately, yes. Now, as it passes up, it targets this thing called the ventral posterior lateral nucleus, right? And what is that? Well, they have an internal capsule on either side. This is just for a left or a right. I didn't have to do left or right. I just did it because I thought it would, like, you know, show symmetry. But if we're just going to the right side, we're just staying on the right side. Now, the projection, right, the posterior 1/3 of the internal capsule projects a bunch of white fibers known as like bundles, right? So it gets this fiber, right, from the internal accruent fibers. It gets it, it receives it. When it receives it, it stimulates another fiber or it connects to another fiber. Okay, what am I even saying? So when it connects to another fiber, like this, right, in that box, holy crap, this is our third order neuron. Why? Well, another fiber is connecting to another one. It's another order. Where is this happening? This guy's happening at the thalamus. Okay, not bad. So now when those fibers, right, they come out of the thalamus region, what are they stimulating? Well, they're going to then stimulate, they're going to spread out like, it says a projection of white fibers. Yeah, it's like this, right? And what's it going to target? The homunculus. What is that guy? Well, this guy, I'm not going to go into great detail of him, but you have the brain, right? That's a really poor drawing. You have two sides of the brain, right? And now there's a diagram on the internet or something you can look at. I'll post it in this video, actually, right after. But the diagram just shows different regions of the brain have different functions. Okay, so if one of the fibers, right, targets, say, like this region. Okay, I'm going to target the head. This region, the nose, the eye, the lips, the arm, the leg, the foot, the toes, etc. All around this different region of the brain. So that's what these fibers are going to target. They're going to hit the homunculus. Anyways, that's the first pathway, the first sensory pathway. All it's doing is sending sensory information to the brain. I'm going to talk about the next pathway now. What is the next pathway going to be? The lateral column. What was that? Anterolateral system with a spinal thalamic tract. And where is he coming from? Right over here, the lateral matter. And what does it have? Ascending and descending fibers. So if you want to just skip to that video right now, just click the link. If you want to stay and watch a couple questions and practice it, feel free to do that too. Anyways, I hope it helped. Alright, so quick question. A 60-year-old man diagnosed with neurosyphilis 1 year ago visits his neurologist with a complaint of uncoordinated walking. Alright. On examination, the physician notes that the patient has a high stepping gait and decreased vibration and position sense in his lower limbs. Alright, so what is relevant so far? Vibration, position sense in his lower limbs. Well, if we didn't know what we were talking about, like if we didn't know we were being asked on the spinal tracts, what else would be important? Well, also a high stepping gait, we would think, oh, okay, well this has to be something with what? Trendelenburg sign. And this would deviate into two different types of muscles and nerves. You could think the gluteus max and the gluteus or min. But whatever, we're talking about spinal tract, so we're not getting down that rabbit hole. Okay, so decreased vibration, position in his lower limbs. Okay, so that's the only important thing we need to know right now. Let's keep reading. Let me erase this real quick. Okay, vibration and position sensations are normal in his upper limbs. Okay, so his upper limbs are good. So we're going to write lower, bad, upper, good. Okay. A lesion in which of the following labeled structures would result in the patient's condition? Okay, so let's think what we just talked about. Where is lower going to? Well, if it's lower limbs, I'm automatically thinking T6 below. I'm thinking Fasciculus Gracilis, right? That gracilis muscle. I don't know, a good way to remember it. And if I see upper, I'm thinking T5 and above. And what am I saying? I know this is the fasciculus what? Fasciculus cutaneus. But what do they say? Upper's good, so we don't need them. Okay, so the problem with the lower, right? And then all it's asking us is where is this lesion going to be? What are they even giving us? So let me redraw it in my own way because I like my pictures better than that crazy diagram. And we know it looks like this. Okay, so if we match our own diagram, like my diagram to this one, what do we have? Well, E is pointing to what? The anterior gray horn. And what did we say this was used for? Well, this is for motor, so this is automatically out, so we could cross out E. E's a goner. Okay, what is D pointing to? Well, D is pointing to white matter, right? So this might be right, because it could be a tract. Where, though? It looks ventral. Could be a little bit lateral, but we don't know. What's A pointing to? Well, A is also pointing to white matter, but it's pointing to lateral white matter, so he could be right too. What is C pointing to? Well, C is pointing to what? Well, the posterior gray horn. And what was this for? Well, this was for sensory info. So this could be right. And what about B? Well, B is pointing to the dorsal. White matter, I'm sorry. White columns. The dorsal white columns. And what was this guy? Well, this guy was the medial Luminiscus pathway. Okay, so whatever. Let's keep going. If we don't know what they're talking about. So it says decreased vibration and decreased sense. Well, vibration and sense, right, comes from where? Vibration or proprioception. This comes from one of the things we spoke about. The medial Luminiscus pathway. But how? Well, the Fasciculus Gracilis and the Fasciculus cutaneus, both of them do what? They pick up proprioception, vibration. What else did they pick up? Fine touch, the 2-point touch. They picked up stretch from the Golgi tendon organ, the intrafusal fibers with the nuclear chain and the nuclear bag. They picked up the free nerve endings from the paratracheal nerves. So they did a lot of things, but mainly they did the two things they're asking for in the question. Okay. So where were these guys located? Well, this was the medial lemniscus pathway. Where is the medial lemniscus pathway? Well, he's in the dorsal column. So this is the dorsal column. So B's got to be our answer. Let's see. Why is it not D? Well, D, it's a different pathway, and this is in the ventrolateral root, so that's wrong. A is in the lateral root, so this is going to be in the spinothalamic tract or the anterolateral system. So that's not doing what their question's asking. Why can't it be C, though? I thought C does sensory. Well, it does do sensory, but does C really do anything with the tract? No. C, all C really is, the posterior gray horn, it's a root, right? And this root picks up the fibers or the signals that are coming through it. And where does he send it? Let me do a different color. Where does he send these signals? Well, he could send them here, for example. He could send them here. He could send them here. So all C does is receives the signals and puts them somewhere else. So he has nothing really to do with this question stem. So that's why our answer is B. Well, I hope this video helped. I hope to see you guys in the next one.